Hi everyone, my name is Abel Greykatoma. I'm from GREYTEST Design Consult. This is my WhatsApp contact. You can reach me on this number or you can call me on any of these numbers, okay? Today I'm going to be actually taking you through a building design from the scratch, from start to the finish, okay? We are going to be doing a complete building design using Protastructure. Okay, I'm going to be showing you how to import your file directly from your AutoCAD and how to set it the right way before you import for Protastructure to be able to recognize your columns, okay, and the grid lines properly. Okay, I will take you through that process entirely right away. Like you know, we have covered structural designs, mechanical drawings, and electrical, covered structural, road designs, water designs. Okay, if you want to actually check out some of our trainings, you can go down below the description of this video. You find a link to that channel. Just visit the channel and keep yourself busy. Okay, I'll come here. Let me try to open this file now. I'll try to use the AutoCAD 2023 rather, to open this particular drawing. Okay, it's actually still loading. Okay, so you can see this is the AutoCAD file. Firstly, there are two things I would like to check here, because if you don't check and put this thing in order, the Protastructure itself may not actually recognize your columns. Okay, so if you come here now, you can see, make sure that this is actually in a polyline. Okay, make sure that your column is on a polyline, and make sure that it's actually on the column layer, okay, or whatever layer you are giving to it, that is the layer you are actually going to trace when you go back to the Protastructure. Okay, and then this, make sure it's actually on a grid layer. But here now I will have to on the Protastructure look for this column, this layer, which is my grid, and use that for my grids. Okay, and then for my column. So in essence, the point I'm trying to make is you have to take note of the layer for your column, and it has to be a polyline. Okay, I believe you understand what a polyline is. You can use PL for polyline. Okay, and when you take your line, okay, so this is how to come about a polyline. Okay, so instead of using a normal line to generate to represent your column, use a polyline instead, and wherever you have an intersection between two grids, the Protastructure will be able to recognize it as a column. Okay, so let's go right straight into it, and then make sure you save this as a DXF file. So if you save as a DXF file, just come to DXF and save to whatever DXF format you want to save it. By the time you save it as a DXF file, Protastructure will be able to recognize it. So the first thing you will do is, when you come to new project, okay, then you specify the template, that's the code of practice you want to use. So let's say I give this a name, complete design, because the reason why I'm using an underscore is because Protastructure does not recognize you spacing, so you can't space at this point when you are trying to give a name of a project. So you have to use any of these characters. You can see it's showing us the list of characters that you can use. So I always like to use underscore. Okay, so if I click on OK, so it's actually loading. Okay, so when it finished loading, although it's still loading, so when it finished loading, the first thing you do is to come to external reference drawing. Okay, so if I click on external reference drawing, I can also use DXF import, but I will suggest you always make use of external reference. The essence of external reference drawing is that whatever you can update the changes, you can make changes to the Protastructure, to the AutoCAD file in your while you are at AutoCAD, and you come here and update it automatically. So and it will take effect here. So that is the essence of you using an external reference drawing. It's very important that you actually make use of it. So here I will come back and I will look for this. You can see they are all DXF files. So I'll click on open. So it's actually importing right now. So here I will click on active here. So this is just a 2D, so even if I activate the 3D, there will be no use at all. So I can use the existing color from the AutoCAD file, and then I'll click on import. So by the time I click on import, if I come under this my grid, you can see the layer here is under my grid. Okay, so by the time I change this to another layer, it will not display my column and the grids. Okay, and then you can see the column is under the layer, it's actually column, so it recognizes that layer is very, very important. So you must take note of your layers. So if I click on import, it will load the entire project. After it has finished loading it, you can see here it's telling me the number of grid lines will be converted to grid 19, number of polyline converted to columns, which is 40. So we have columns that are up to 40 in number in this particular project. So I will click on OK. So by the time I click on OK, you can see my drawing here. So this is actually showing me all my columns that are in the project based on how I place them in my AutoCAD file, and then my grids are here. I can as well rename some of these grids. Okay, I can rename some of these grids. I can just highlight the grid and probably give it a different name from whatever is there. Okay, so if I come to the property of this grid, you can see this grid A1, A11, A12, 16, 19 and all that. I can as well change their name to probably grid 1, grid 2, grid 3, grid 4, 5, 6, 7, 8, 9 and 10. Okay, so I can also change the direction. You can see this is direction 2, 2, 2, 2, 2, 2, 2. Okay, I can change it to direction 1, 1, 1, 1, 1. Hidden axis. Okay, I can make it hidden, but there's no need for all of that. And then I'll click on my close. So you can see it has actually taken the name of this grid, but it's not really properly arranged, probably because of how this whole grid has been scattered from the import. Okay, so I can as well do the arrangement properly by selecting. You can see I have to make 9 2, I have to make 8 3, 5 4, like that. So you can take out your time to do this editing properly as you want it to actually reflect here in your drawing. Okay, then the next thing here I'm going to do is to actually insert my column. But before I my column is already existing, sorry, and you can see this is telling me column 1, column 2, column 3, column 4, 5. So it's properly arranged, the column is properly arranged. Okay, so what I'm going to do right now is to actually insert a beam, but I will specify the number of stories first, and I will click on insert story. So all I need to do is to just highlight, right click on these stories, and I'll click on insert story, or I can come under my stories here and click on this drop down menu, and I'll come here and I'll click on insert story. So yeah, as you can see, this is just how the interface of Protastructure 2022 as a beginner, if this is your first time you are coming through this software. Now you can see this is the building set out. Now you can see all these tools that are here. You can import, you can you can import from Safe, you can also import from Revit. These are softwares. Okay, then materials. This material property is where you can actually change your size of a reinforcement, specify the thickness of the reinforcement, you know, and the characteristic strength of your steel, characteristic strength of your concrete. You can specify all of that. If you are doing a steel design, you can also specify the grade of your steel. For your timber, for example, you are going to be having a formwork. In that case, because Protastructure can as well do a formwork design for you, you can as well specify the timber frame member. Okay, so it has sheeting as well, which you can also specify. So these are actually basic tools you are actually going to be making good use of as you proceed in the training. You can see here has a settings where you can do some of the necessary setting, as in specifying the minimum and the maximum size of reinforcement you want to use on each structural member. And then this has the layers where you can actually specify your layer, the color, the shading. Okay, whether you want it to, you can specify how you want the layer to look like, just like the AutoCAD. If you are very much familiar with the AutoCAD environment, it's the same way. So you have a project template, you have performance mode, display setting. Also here you can actually be able to see where we call the visual interrogation. The visual interrogation help you in knowing okay, we've talked about setting, we talk about the unit format. Okay, you can specify the unit of your design, if you want to use the metric unit or you want to use the imperial unit for your design. You can actually specify that. You can specify all of that in your design. Okay, you can also pick a template from the beginning, which I have mentioned. You know, we have different kind of design standard of practice. We have different code of practice. Okay, in Nigeria we mostly use the British standard, and then the European the Euro code as well, European standard. Okay, so but like you know, there's a whole lot of similarities between the two code of practice. Okay, as we proceed, you are going to be seeing all of that later on. You can see load libraries. We have the partition, wall load, slab additional load. You are going to be seeing all of this even as we progress in the training. Okay, so if you are able to get to this point, I tell you a very big congratulations. The next thing you are going to do is to insert a beam. And if you come to your modeling tab, just as the name implies, modeling, here you can be able to do your entire modeling, all the basic tools that you need to achieve your model are actually here. You can see we have the grid, we have the axis. Instead of importing this with the axis here, you can as well do manually insert your grids from Protastructure even without importing. You don't necessarily have to import, but it's much more easier and faster to import your drawing from AutoCAD, most especially when the architect gives you your drawing. It usually comes in AutoCAD format, so you do your general arrangement in AutoCAD before you import. But here now, if you don't want to do all that stress, you can probably, which is much more easier, is not a stress, sorry, but you can actually do the sketching manually on a sheet of paper. Probably maybe you don't know how to use AutoCAD. You can as well come to this point and click on your orthogonal axis and click anywhere around the window and specify your grid point. By the time you specify your grid point, you can as well come to your column here and insert the thickness of your column. Insert the thickness of your column. As you can see, as we are inserting is taking place, if you come to your beam, just as the name implies, is for beam, and then you can see you can insert the cross section of your beam, which is the width here is 250 and then the depth is 500. So similarly for every other structural member, let's say you have a slab, you can also insert a slab. So even without you importing any drawing, for example, you don't know how to use AutoCAD, you can as well make use of your axis from here. All you need to do is just a pick and a drop. If you click on my slab now, I can come here and I'll click on loading generator, and I'm going to be explaining all of this even as we proceed. Then you have the loading cases. Click on OK and I click on OK, I can just insert my slab. So I can specify the thickness of the slab if it is 150 for example, and I come under my loading and I will specify my life load, type in my dead load, or I just pick from the classification. So let's go back to the main project itself that we are actually trying to achieve. So what I will do now is to click on my beam. If I click on this beam I'm going to be using a 230 by 450 thickness of beam. So all I need to do is just to come here after specifying here the cross section of that beam. So I will come here and I drop, I come here and I drop, I come here, okay. So in the main design I have an expansion joint here, so that is why you are seeing this space. You know, you have to always introduce an expansion joint whenever you are doing whenever the span of your building is getting to 30 meters span. It is by code of practice you are supposed to introduce an expansion joint, okay? But I learned that there is a little change now that the span can even go more than 30 meters, although I stand to be corrected, but I still maintain the 30 meter span in most of my designs. But I learned it goes up to 40 meters now or thereabout, but based on what I used to know, it's actually in 30 meter span. So if you have a 30 meter span, it is actually professional for you to introduce an expansion joint, okay? So you introduce an expansion joint, that means you are actually cutting the building, making it completely separate from the other building, but they are very, very close to each other, okay? So that's in essence what an expansion joint is. So but you see there is a little I think there is a small beam here which is not supposed to be there. There's another very small beam here which is not supposed to be here as well. So the building is supposed to be completely separate from each other, but very, very close to each other without anybody noticing that you have two different buildings but very close to each other. That's in essence what an expansion joint is, okay? So these are two separate buildings, but they are close to each other. Okay, so sorry, this design is way more larger than this. Whatever we have here is exactly what we have on this other end, so I just cut just half part of that building, and that is what I have here. Okay, so but whatever I have here is exactly what I'm having on my right hand side, so there's no need of me reproducing this. So the whole thing that is here is similar with what I have here. So that is the reason why I only cut half part of it to analyze and design here in this particular project. Okay, so in this case now, since we have inserted most of our beams. Okay, let me try to insert all the beams first. So by the time you insert all my beams, I'm going to insert another beam here, insert another beam here, insert a beam here, and I will insert a beam here. There is no column here, which is definitely going to fail without a column. Okay, column, so start a column here, start a column here. Okay, so I've been able to insert the necessary structural members. All I need to do now is to come here now, come under my views, and then I will click on 3D physical model. So if I click on 3D physical model, it's going to be showing me this particular building in 3D form. Okay, so you can see this is what I have in 3D. This is what I have in 3D, which is amazing, right? So now I am going to actually at this point just generate my members to the other floors, to the other story. Okay, so in order for me to do that, I will come here. Let me come to my view and I will click on tile vertical. I always like to have this. Okay, sorry, view, plan view, and okay, all right, I'm there now. So I will generate this member to the other floor. So to do this, I will just have to highlight all of this, and I right click, and then I will click on generate member to other floors. Oh, that's, I think I did something that is not correct somewhere. Okay, generate members to other floor. So I already have one floor here, which is not supposed to be so. I'm supposed to insert a story. I'll come to story here and I'll click on insert story, and I'll insert 2 as the story, and I'll click on yes. Nice. So now I'll come back to my story 1, and then I will highlight everything here in my story 1, and I will upload it. I will generate it to my story 2. Okay, so all I need to do now is just to click on, I'll highlight the whole of this beam, the whole of the design or my whole model, and I'll select story 2 and I'll click on OK. Okay, so that has been generated, and then I will click on OK. So you can see, if you view this from my 3D, you can see what I have. So I'm having a total frame of this entire building. So you can see this is the entire frame of this building. Okay, so but you know, at my story 2, this is 230 by 450, but that is not what I want to use. If I come back to my model view and I'll come to this one that is called filter, if I come to that filter, I will click on, I'll deselect everything here and I will select beam, and then I will highlight the entire project. But you know, my filter now is only going to select only my beams. So if I come to the property of this beam, what I'm going to do is to change this particular depth of this beam to 300, because it's going to be carrying just the roof load. So this is now going to be 230 by 300 size of beam. Okay, if you already love what you are seeing, just like this video, make sure you give it a thumbs up. Subscribe to this channel, it's actually 100% free. Click on the bell icon so as for you to get a notification whenever I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Okay, now you can see here now, if you zoom this, you can see from the 3D, you can see that this beam is looking bigger than this, which is very okay, and that is exactly what I want. But mind you, I have not inserted my slab here. Okay, so I'll come here and I'll click here, and then I'll double click on story 1, and then I'll come to my slab. Then I will insert the thickness of this slab to be 150, and then I'll come to the loading here, and then here I will make this let's say I use 5.8 value, and then my life load here, I'm going to pick on the class of building. So this building is actually not a residential building. So if it's a residential building, all I need to do is just to click on this, but it's not residential. So I will come down and I will check what this building actually fits into, what category here. So it's exactly what I'm going to look for, and then I will select that. So this is community kitchen, okay, communal kitchen, toilet area, hospital, bedroom, hotels and motels, toilets, balconies, theater, workroom, offices for general use. Okay, I think I'm going to pick on offices. Okay, nice. Shopping area. So the design is actually design of shops. Okay, so because these are actually shops, so I'll pick on the shopping area, and then I'll insert all of that. I'll insert, this is the type of slab. Okay, and mind you, in this Protastructure, there is one great thing about this software that it does for you. It can help you automatically place your give your slab its type, okay, and give it its original type, even without you manually doing all of that, which is going to be a whole lot of stress. For example, now I'm going to show you this particular slab. You can see this is a slab that is actually two-way discontinuous and two-way continuous. Okay, so it's continuous in two in this area, in here as well, but it continues here and it continues here. Okay, so it has two adjacent edges that are actually discontinuous. All right, so if you look at this now here, so it actually looks more like this slab panel 4, okay, which is actually continuous in two edges and it discontinuous in two edges. So but you can see I just placed the slab without checking the slab type. So in that case, all I need to do is to come down to this area, and I'll come under my review. If I come under review, I am going to, firstly, I can delete every unused axis but I don't have any axis that is unused, because sometimes when you import your file from AutoCAD, it comes with some other axis probably that you must have forgotten to remove in your AutoCAD file. So you can just use delete unused axis and it goes off, or there are some axes that you must have introduced unconsciously. And then if you can remember, when I was pasting this slab, I did not follow it in the right order. So I'm supposed to start by coming this way, 1 2 3 4 5 6 7 8, like that, in that order to the end. Now this is showing me this is slab 1, this is slab 2, slab 3, slab 4, 5, but there must be probably a mistake somewhere along the line. Now you can see this is 9 and this is 10, so this is supposed to be 9, this is supposed to be 10. So in whatever way, you must have probably made an error in placing those particular slab. You can actually use relabel members, and if you click on yes, it will bring you here and ask you what particular member do you want to relabel. So all I like to do is to select the entire structural member, because probably while I was modeling there could be some human error. So this is well arranged for me now at this point. So here I can also use the check slab thickness or check wall thickness, or okay. But here now what I want to do is to use the automatic slab type. So if I highlight all my slab here now, and then good, now you can see automatically it has bring me to the properties of my slab. Now you can see set slab type automatically. So if I click on this now, it's going to automatically set all my slab to the exact type that is supposed to be. Okay, apply to selected slab only, apply to all slab in the story. So every slab that I selected here are actually going to take effect, but I can also use the apply to all slabs in the story, but I only have slab in just the this first floor. Okay, that's the only place I even have my slab. But if I have other, probably like a multi-story, okay, in that case I can probably just use this and it will automatically take effect, or apply to all slabs in a model, so in the entire model is going to take place. Okay, so because sometimes you can have up to 2-3 different kind of projects in one particular Protastructure window. Okay, so in that case you can actually use for a single model, or you are going to use for the entire building or design that is actually building project that is actually in your model. Okay, so if I click on OK at this point, it's going to help me rearrange this properly and give it the original type that is supposed to be there. So automatically, if I double click on this now and I come under this property, you can see it has automatically placed this slab to the specific type that is supposed to be there. Okay, so which is one great thing about this particular Protastructure. So it actually makes your work a whole lot more easier and more faster. You can achieve a whole lot of design using Protastructure. It's a very great software, which I will encourage you, if you are just a beginner or you are just coming across this software for the first time, I will encourage you to really put your mind to it, because you are really going to enjoy designing with this software. It's very flexible. You can achieve a whole lot of kind of model using this particular design. Okay, the next thing now I'm going to do at this point, after getting to this level, is to come to my beam. Okay, I need to insert a wall load for my beam. So to insert a wall load is just to select one beam. If I select any of this beam and then I right click, I can come to edit load. If I click on edit load, it's going to take me to the load loading properties, because we have different kind of load that you can apply in your building. Okay, so it will bring up this window for different type of loads. Okay, so now at this point now I will come to my wall load. You can see I have point load, I have uniform load, partial load. All of this, probably as you proceed in design, you able to see how this load actually come to play in your designs. Okay, so here now I'm going to be applying this wall load. So to apply this wall load on my project, all I need to do is to specify the thickness of the wall that is going to be on this particular beam, the height of this wall that will be on this particular beam, and also the wall unit weight that will be on this particular project. So I'm going to be using 3.4. I will encourage you, if you're a beginner, to actually get the book Victor Oyenuga. Okay, Simplified Reinforced Concrete Design by Victor Oyenuga. He has two different books. He has the one for foundation, he has the one for building project. I will encourage you to get it. The one for foundation covers every aspect of different type of foundation. All types of foundation were actually taken care of in that book. And then when it comes to the building reinforced concrete, Simplified Reinforced Concrete Design by Victor Oyenuga, it's actually also very great, where you are going to see all of these structural members come into play, how these loadings are being distributed from your slab to your beam, from your beam to your column, down to your foundation. Interesting. You are actually going to enjoy getting that book. You can as well even get it from me. If you are a beginner, just contact me. You can get it from me wherever you are in the world. We can waybill it to you and you get it in no time. Okay, so now the next thing I will do is just to come here and I will drop this wall. So the moment I drop this wall, I can as well even create an opening. So if I click on edit opening, I can insert an opening for this. I can add an opening, probably let's say like a window. Maybe I want a window. So you can see this is the dimension of my window. The width of the window is 1000, the height of the window is 1000, and then it has been centralized to 225.2.5, and then the height here is at 1 meter, but I always like it to be at 900. It is always in 900 if you have a 3 meter height of your building, and then the wall thickness is always 1200. 200. Let's assume that this is the thickness of our window. So you can just check if you have this, check what is the length here. Since I have 1505, I can just actually subtract the width of 1200 from it. If I subtract 1200, I'm going to be having 305. If I divide 305 by 2, so whatever value I'm going to get is what I will just insert here. So let's just do that mathematically. First, 305 divided by 2, we are going to be having 152.5. so that is exactly what I'm going to type in here. For example, if I want this window to be centralized. Okay, so if I click on that, and then I'm going to click on OK, and it's as simple as that. Okay, and I click on OK, and I click on OK. So that particular window has been created. Okay, the wall has been created, but the window has not really reflect. So I can also click on this beam, click on the beam, and come here, and I will click on edit load. So I can come back to that wall here, and then make sure what I'm doing was correct. So this is 1200. Okay, this is 152.5 if I'm not mistaken, and then I made this 900. Okay, it's opening. What is wrong with this? Okay, select members by picking or drawing a window for load assignment. Okay, okay. So the opening has been created. So the next thing you do now is to copy the load. Now you can see the only load we have here presently is just our wall load. So I'm going to copy this wall load and I'm going to highlight everything, because wall load can only be applied to only beam. So even if you highlight the entire structural member, it is not only going to be pasted in your beams. Okay, so you can take out your time to do the editing for each particular member, okay, because some of these may not really require an opening. There are some of the opening that are not needed, okay. For example, this area, we don't even need this opening here. So there are some of these opening that are not required in some of these areas, so you can as well just manually delete them. Okay, so I can just select some of the beams that I know I don't really require a what they call it, a wall load. So if I use my filter and I select just my beam, so I can just highlight some of these beams, or I can as well manually just select the beams and delete the load. Okay, because this load may most likely not be a wall. Okay, so it could be railings, it could be wall. Okay, so it may not necessarily be a wall. So I will just delete load and I will click on OK. So you can see all that load has been taken out. So I can as well just probably insert a, I can just insert, it can also be a wall there, maybe like a dwarf kind of wall like that, maybe a wall of height of so if I come to edit wall, so it depends on whatever that is there based on what the architect has given you. So your loading here can probably be let's say the height here 1 meter. Okay, so let's just say is in 1 meter height, so it may not be up to, which will most likely not be up to what you are using. So there is a mistake here though, I would have to edit it. So you have to do all of this manually for all of them. actually, or else so if I come to edit load, there is a mistake in what I just did. So everything here is 1 meter, okay? So, and then I'll click on OK. So this one does not have an opening. What did I do? Edit load, wall load, starting height 1 meter, and I'll have to probably delete this first. Delete load, edit load, come to wall load 1 meter, and I'll click on OK. Edit load, come to wall load 1 meter, and I'll place it. You have to always place it, or else it will not reflect. Okay, so whatever I have here, I can just copy this load, click on OK, and then I will select the beams I want to place this load on. Okay. So I'll now highlight, right click, and then I'll paste load. So you can see what we have now. So similarly, I'll do it for okay, it has reflect everywhere, which is okay, nice. So so in some cases it could be railings, okay, not necessarily what we have like this. So we're able to model this to this point. Let's just assume we have all of this as it is like this, but you know, this could probably be a door by the side. So similarly, you can just right click and come to edit load and use the door instead of having a window there. So you can click on edit load and add, and then the width could be, let's say, 1200, and then the height of that door is 2100, and then this level could be, let's say, 50. Okay, so if we have it like this, you can click on OK, and you can click on another, then make sure you are selecting the wall, and you can just probably delete it if it's not taking too much of your time to really achieve. You can as well just delete the load and select the load, edit load, and come to your wall load and create an opening and add. Am I selecting the right wall? This wall. Alright, click, edit load, come to wall load, edit wall load, okay. Firstly, I have to specify the wall. Okay, this is the wall. Now edit this wall, add the width 1200, height 2100, then this, let's say 50. Okay, so I'll click on OK, and I'll click on OK. That did not take place. Why? 1,200, 2,100, 50. Okay. Okay. So you can take out your time to insert that load. The next thing here is to actually come to my building analysis, but before then it's important you add a load to your roof load, to your roof. Okay, so you can add a load to your roof by simply coming to story 2. If I come to my story 2 now, if I come to story 2, I can use it in form of like a wall. I can also use it in form of like a slab. So let's say I insert a wall which is going to be in just 1 kilonewton. I'm going to be using this, and I'm going to make this just 1 kilonewton per meter square, and I can probably just make the height not very high, maybe 1 meter. Okay, it's just to wall unit weight. Okay, I don't want the weight to be more than just a meter. Okay, so that did not take place because I did not place it. So this is going to be just one, this is going to be 1 meter height, and then I'll place and I'll click on OK. So that is imputed already. I'll highlight, I'll copy, and I'll click on OK, and I'll highlight all my beams because I just want these beams to have 1 kilonewton per meter square. So that's the simplest way to add a wall load, a roof load to your beams. Okay, so you can as well probably use your slab as well to just subject it to a load of 1 kilonewton per meter square. Okay, so if that is correct, so I have loaded, let's say this entire building has been loaded accordingly how it's supposed to be, but you know, we are supposed to be having door opening in these areas, so instead of windows you have to make them doors. Okay, so it's similar, just the way you did for the windows, the same way you apply for your windows as well. Okay, the way you did for the windows is the same way you apply for your doors as well. So by the time you are able to achieve up to this point, you have successfully done your modeling entirely. So at this point, you just need to come to your analysis, and you come to your building analysis, and then you are going to set your entire material. Before you do that, you can come to your setting center. When you come to your setting center, your unit, you know, it's already intact. Your columns and your beams, you can just come to your reinforcement to check your longitudinal bar, what size of reinforcement, the minimum size and then the maximum size, and all of that. The same way you do for your column is the same way you do for your beam as well, similarly for your slab as well. So before we do that, I'll click on OK. I'll click on OK. Let me click on OK here. Okay, let's come to this same. Now you can see your code here is BS8110, BS5950, that's for steel. Loading code is 6399 and all that. You can as well change it. Probably maybe you made a mistake while trying to select the code of practice, so you can do that little setting from there. Loading combination, you know, this building is just one-story building, so yeah, there will be no need for your wind load. So you click on OK and you click on OK. Okay, so all of these are actually intact. The next thing we'll do is to select our material. Make sure that your column grade of your steel, grade of concrete, you can see from the setting here by default is 20/25. This one is 410. I'm going to leave all of this exactly as it is, but for the reinforcement on each of these structural member, I'm going to be selecting the type of reinforcement I want the software to actually make use of for me. So I will come to edit here under rebar diameter. If I click on that edit, it's going to bring me here. The first one you can see here is our column, so I will specify the type of the reinforcement I want the software to make use of. This is just a one suspended floor, so just Y16 is very okay for this building. Then I have a beam here, also Y16 alone is okay for this. I don't have to select any other reinforcement. So if I come here for my slab, Y12 alone is very much okay for this design. I will deselect every other reinforcement, and then I'll go to my foundation here, which is my footing. I'm going to be using Y12, and I will deselect every other reinforcement. So these are not constant, please. You don't have to cram it this way. Okay, so designs are different, the loadings on designs are actually different, the entire height of your project, we have buildings come in different stories and all that, so these are not constant that you should cram. Okay, then your links, I'm going to be using Y10, so for my entire links. So and these are the only structural members I'm using in this particular design, which is beam, slab, column, and your foundation. And then we have our links as well, which I said I'm going to be using just Y10 for my links. So by the time I'm able to do all of this setting, I can come for that of my foundation. You can see here I can specify the type of soil that I have there on the foundation, probably based on the soil report that has been given to me, okay, by the engineer in the lab, from the lab. Okay, so the soil report I'm getting from there is the whatever I'm going to specify there. So if everything, for example, is correct, all I need to do is to now come to my analysis. Okay, but I can as well do some little settings specifying the foundation depth and all of that, which I did not specify from the beginning, which is a very big error that I made. So from here I can come to edit story and I will check what is the foundation depth. So I'm going to make the depth of this foundation 1200, for example, and then my story height, each story is 3 meters, and I'm going to leave it exactly as it is. So but there are cases where you have your story will most likely be different, the height will be different. You know, different kind of building comes with different kinds of height of those particular building. For example, if you are dealing with a project that has to do with probably like a warehouse, the height will most likely be different. We are dealing with a project that has to do with like a church, the height will definitely be different. Or a mosque, the height will definitely be different. The height cannot be 3 meters. Okay, so these are some of the things, but the architect will actually provide the height of that particular project. All you need to do is to maintain that particular height that you get from the architect. Okay, so these are some of the things you need to really put into put in place before you run your design. So if everything here is actually in order for me, so the only thing that will be remaining for me now is to run my analysis and run my design. Like I said, you have to always check all this and make sure everything is in order. Okay, the title, okay, so it is designed, calculated by who you type in the name. So whoever drawn by who is going to do the drawing, and then the project client's name, project title, project number, project date, project address, and revision. So all of these you can put them in order before you run your analysis, because your analysis will most likely reflect these informations. Okay, so you can put all of that in order, and then you can have some kind of so you can as well so you can have some kind of notes. Okay, so you can just write some kind of notes which you are going to be including when it comes to your design. Your foundation, make sure you specify the type of soil, the allowable stress of soil, okay, which is actually the soil bearing capacity, which is actually gotten from the soil report. So these are informations, this one and this one gotten from your soil report. So your soil report will tell you that all you need to do is to come here and impute that value there. So by the time you impute that value and everything is very okay, the next thing you do is to do your building model check, and then you click on start. Alright, so by the time you are done with your building model, you can see that the number of errors here showing me is 0. But if you have error in your model, it's going to display, and by the time it displays that error, you come to load log to editor. Okay, so if you come here, it's going to tell you specifically where that error is coming from. Okay, and then you have to go back to your model and correct it. By the time you correct it, that error will no longer show in your model. So by the time you are done with that, the next thing you do is to come to your building model analysis. That is the next thing you need to do. Then you check this, and you check all of this, and you click on building analysis. So you allow it to analyze, because at the moment it's actually analyzing the building for us. All right, it's still loading. Alright, so by the time you are done with the entire analysis, you now go to your post analysis. From your post analysis, you'll be able to see all the structural members you have specified, the ones that failed and the one that's passed. Okay, so you can see one particular column there showing us that it has failed with a red indication here. So all I need to do is to check this particular column 1C1, so one building analysis combination is actually not found. Okay, so we select all bars. So it was actually asking for this it was asking for building loading combination, which is this, and okay, loading and load cases. So let me come back to my building analysis. Let me reanalyze it. But if it persists, you can just delete the column and reinsert another column there, okay, and then rerun the analysis, because it's not supposed to fail at all. Alright, so now come to post-processing. Let's check our column again. Nice, so everything has passed this time around, so we don't have any issues with our columns. Let's go to our beams and let's see if they all pass through. Okay, which is nice. And then let's now come back to our stripping. We have to do a slab strip. Okay, so to do slab strip, in order for it to generate your slab detailing for you, so you have to strip it. So this is X direction, this is Y direction. X direction means the horizontal direction, the Y direction means the vertical direction. And you have to always check. Here you have a beam, starting with a beam, you are ending with a beam, and then you have to check that particular beam, is it a cantilever or is it just a normal, that slab. You have to check whether it's a cantilever slab or it's not a cantilever. So if this is a cantilever, now I'm starting with a cantilever and I'm ending with a beam. So the Now it's telling us the section is not sufficient. In that case, you probably need to increase the depth of that particular slab. Okay, and yeah, that's basically all you need to do, is to increase, probably try to increase the depth of the slab or change the spacing of the reinforcement. You can do that setting from here. If you come to our settings here, if you come under this setting and come to slab setting here, come to rebar. If you come to rebar, you can see it's telling us the bar spacing is 250. I can make the maximum spacing to be 200, for example. So if I make it 200, whatever stripping, whatever reinforcement arrangement is going to make for me, it's not going to be less than above 200 spacing. So you can actually try that. If it's still failing, you probably need to change the thickness of this particular slab. So if I change this slab thickness for this other next one, and I change this thickness to, let's say, 200, for example, and I'm still going to try to strip this and see whether it will pass or it will fail. Okay, still not sufficient. So this one, it requires probably a more thicker depth of slab. Let's say a 250 depth of slab, and I use this strip, and I will hold on my control key to see the slab cross section is still not sufficient. So you have to actually make sure that it's sufficient. Okay, so these are the things you have to always put in order. You have to check the thickness of your reinforcement. You have to check the spacing of the reinforcement. You also have to check the thickness of that particular slab. Okay, so by the time all of those things are in order, the slab will definitely pass. So let's check what we have here, and you can see the minimum steel bar is Y12, which is very okay for us. You can see here we are having Y12 at 200 spacing, which is okay for me. Okay, so similarly, you do for the way you do for the horizontal is the same way you do for the vertical as well. So we may not go into the process of trying to fix this particular slab. Okay, but let's switch this to vertical, and I have a beam here, I have a beam here, so I can hold on my control key. Oh no, what is going on here? Slab strip. Okay, this is starting with a beam, which is this, ending with another beam, which is this. So you can see vertically it's actually not giving us problem. I'm starting with a beam at this point, and I'm stopping at a cantilever. You know, I've already called this and I've called this. So I'm starting with a beam and stopping inside a slab. So that is just what this boundary condition means. So this is a beam, and then I'm stopping at a slab. So this is exactly what this particular condition means. Okay, so you can do that similarly for all. This is beam, this is a cantilever. So if I'm starting with a beam and I'm stopping in a cantilever, I can specify that. So the cantilever has always been failing, probably because of maybe the reinforcement or the thickness of the slab, or it could be the spacing of the reinforcement. So these are some of the things you have to probably put in order for it to actually pass. So if you are able to generate or run your strip very well, then all you need to do is to, I'm just trying to make this video as brief as possible because we have actually spent a long time already on this particular video. So but you can actually check my channel. I have actually done a whole lot that has to do with Protastructure design of building, okay, building design, and I've talked about virtually almost everything that has to do with design, both the challenges that you can face and how to fix all of those challenges. Okay, so it may take a longer route for us to try to fix these slab issues that we have at the moment. Okay, so right now, once you have been able to do all of this, all you need to do is to come to under your slab come under your design. You are going to see slab analysis and design. If you click on that, you can see all the strip that has actually passed, and then you can generate your reports here. Okay, so it's very easy. It's just to click on design report. Similarly for your beam, also is the same for the case of your column as well. Just to click on design report. Once you click on design report, you can convert it to either a PDF or you can make it in form of an office. You can make it to office or PDF. So if you make it PDF, you can send it to your client or to an office. You can also send that to your client, or you can as well convert it to any of these two formats and then print as well. So whichever way you want it is actually the same. So you can see the design for our slab is actually very fully ready. So but in a case whereby any of these fails, you can change. You can see the reinforcement thickness and all of that is changing here and all. So you can actually, by the time you make any of this correction, you can come back here and delete and reselect all steel bars. Probably maybe you have changed a thickness of your reinforcement. Once you change a thickness of your reinforcement, you can do all that and probably come back here and update steel bars. By the time you update steel bar, it's going to take the recent particular reinforcement that you have actually used. It's very easy. As you can see, the software is actually very straightforward. The same thing, like I said, if you come to your analysis, come to your building analysis, go to this post-processing where we did our column. The same way you can also generate a report. So you can see here, design report for our columns can be generated. So as many columns that you want to design, their reports, you want to generate the report, you can just simply do that from here. The same thing for your beam as well. And then you can actually generate or send this particular detail drawing to your Prota detail. If you come to this place and you click on Prota detail, it will automatically generate the detail drawing because we have successfully done the design analysis and design of this particular project. But don't forget, we have not done the foundation, which is very, very easy as well. All you need to do is just to go to your story 0. So if I double tap on my story, I have to click here and then double click on my story 0. You can see it will bring me to story 0. Now at this story 0, now all I need to do is to insert the particular footing I want to insert. So if I come here now and I click on any of this column and I right click, I can click on insert part footing. Okay, so if I click on insert part footing, automatically it's going to load and check the axial load of this particular column, because, and I can also make this axial load of this column to actually display. I can make it show here in my foundation level. So you can see what I have here. So I'm going to select square footing. If I click on design, it's going to design this particular footing for me, and it will specify the size of the footing in which I should probably make use of. So you can see this particular column, the foundation is failing based on, I don't know what exactly is making it fail, but let me try to reduce this footing depth, and then I will try to make this 1200 by 1200. So if I try to design this reinforcement, okay, the reinforcement Y0O 250 spacing provided is required. Okay, that is what is required here. So the reinforcement is okay. Let's come to rebar. Okay, 250 spacing, diameter. Okay, so the reinforcement here that is showing me is 000. So there is a problem somewhere, probably while I was trying to actually do some of these settings. I actually omitted the size of my reinforcement somehow. So let's go right there and check what the problem is. So if I come to my foundation level, then you can see my minimum steel bar is Y12, my distribution bar is also Y12, which is very okay for me. Okay, and then minimum part base depth is 400, which is okay. Maximum steel bar spacing is 200, which is very okay. So what I will do is I will make this maximum spacing to be Y50, since it's Y12 reinforcement I'm going to be using, and then I will click on OK, and then I will try to insert this pad footing, and let's see what it's going to give us. Perfect, so you can see it has passed. So I will just click on OK, and this footing has been created. So here now, where I have an expansion joint, you know, I'm going to be having two columns that are actually going to be very close to each other, because this entire building are two separate. Is the same building, but they have been separated completely in all area. The only thing that brings them together is just the footing, but everything about this building is different from what is here. So but the spacing between them is just 20 mm, so it's a very small spacing that people cannot easily take note of. Okay, so in order for me to insert a combined footing, is just for me to select this column and also select the second column, and I will right click. If I right click on this, I will come to insert combined pad footing. So if it is a pile foundation, for example, that I want, I can also achieve that, which is very simple. So if I click on insert pad footing, that footing will automatically be generated. As it is, I'm going to demonstrate another type of footing for us, which is the strip footing. So to demonstrate that of my strip, I will have to introduce a ground beam. So by the time I introduce a ground beam here now, let's say I have a ground beam which is like this. So if I have a ground beam that comes this way, I will select on these beams that are here, and then I will right click and I will insert strip footing. So if I click on strip footing, it's going to generate the strip footing for me. So I'm just going to leave everything as default as it is, and then here footing depth 400, I can leave it as it is and all that. So let's just click on design just for demonstration purpose. Let's say I just want to demonstrate this for us in order for you to, so you can see it has generated a strip footing for me. This is a strip footing, this is a single footing, and this is a combined footing. Okay, so this is basically how to achieve your foundation in your Protastructure. You can see it in the 3D model is actually displaying here. So you can do similarly for every other footing that is here. So whatever kind of foundation you want to generate for this, you can actually generate that. For example, if you want to do a pile foundation for this, all I need to do is to come to this place and I will click on insert pile cap. So I'll have to insert my pile cap, and then the pile cap, then the pile foundation is going to be generated for me. So you can see if I come to the pile cap itself, because this is actually pedestal, so Sorry, still loading. So I'm going to be having 4 different piles, but there is a little manual calculation I did some time ago on piles. So even the piles, you need to know the soil bearing capacity. There's a soil report that is going to be given to you. We are going to be using the axial load of this particular column, but for the sake of today, just take it as it is like this. But if you really want to have an insight on pile, you can go down to my YouTube channel. You find where I talked about pile foundation, how I did that calculation manually, and it actually coincide with the one that Protastructure actually generated for us. It's actually a very great form of knowledge. Even that of your part foundation, we actually did that calculation too manually, and we were able to see how that was generated. So and right now you can even as well show your column the axial load. Okay, the loading that is actually acting on your columns can be actually shown. Okay, so you can make it display. You can actually display that particular axial load when it comes to your column. So if I click on my axial load, if I click on the dead load and I click on OK, so that particular column axial load, good. Now you can see these are the axial load on these columns. So you can see this is 16.4 kilonewton, this is actually 104. So you can display this loading when it comes to your foundation level. So with this axial load, you can use to check for your foundation, the type of the foundation, and confirm what the Protastructure foundation is generating for you. Okay, all right. So at this point, we have actually come to almost a close of whatever we have been talking about when it comes to your design in Protastructure for every beginner, from your scratch to the finish. So at this point, once you are done with the whole entire model analysis and design, all you need to do is just to come to your Prota detail, and by the time you double click on Prota detail, it takes you to the Prota detail itself. By the time you go to your Prota detail, there you can be able to generate your detailed drawing for your project which you have done. So it's actually loading in the background, so we have to actually let it load. Okay, so you can see when you come to your Prota detailing, all you need to do is to come to open. Already this detail is already open with another project, that is why you can see it like this. So I can come and look for that particular project I'm working on right now, which I cannot remember the name specifically. I remember the name I gave to this, but let me check it here. I gave its name Complete Design. So this is it. So this is Complete Design, and I'll click on OK. Okay, so I can click on Auto Generate. So if I click on Auto Generate, it's going to automatically generate the entire detailing for the entire project which I just did now. So that's exactly what is going to generate for me. Sorry, there is an existing project that is still displaying here, which is not what I want. Sorry, that's an existing project displaying there. Let's take it again. Okay, it's still loading. Okay, All right, I have to patiently wait for it to load. Okay, so it has finished. It's almost done. Okay, so right here now I'm going to click on auto generate details. So if I click on auto generate details, and then I can click on draw. If I click on draw, I will click on anywhere around this window. The interesting part about this Prota detail is that the interface, it has a lot of shortcut keys that are very similar with your AutoCAD software. So if you are very familiar with your AutoCAD software, you can actually manipulate this very well, much more easier and faster for you, because the shortcut keys for your move, for your copy, for your mirror, they are very similar with what you have here. Your offset, your line tool, your construction line, your poly line, and all of that, they are very similar. It's the same thing, the same shortcut keys. So if you are very good with drafting and annotation with AutoCAD, for you to do editing on your detailed drawing here is going to be way more easier for you, because all the tools that you see by the right hand corner of your screen, you can see all these tools that are here are the same. There is no difference with the one you normally use with your AutoCAD. So there is a whole lot of relationship between the entire tools that you see by the left hand corner of your screen, and the right hand corner of your screen rather, of my screen. Okay, so it's the same. So every tool you see here are actually basically the same. So it's still actually loading all the structural members. You are going to see all the entire detailing that has been generated by the software for us. My god, still loading. Oh, it's taking a very long time to load. Okay, I don't know, but I think okay, fine, it's done loading. Okay, so you can see this is basically the entire detailing generated by the software for us. So if you are able to get to this point, I tell you a very big congratulations, because you have been able to get an overview of what you can actually achieve with the Protastructure 2022. So we started by importing a drawing, we analyzed, we modeled it, then we analyzed and we designed. Okay, so congratulations, because you have been able to have a very great overview of what Protastructure can do as regards to the reinforced concrete building design. So you can see the tools I was talking about. So it's the same. If you want to copy, you can just type your CO like in your AutoCAD. If you want to move, you type your M, it gives you your move. You highlight, you move, you copy, you offset. Okay, all those particular tools which you are familiar with is similar with what you have here. From here you can export it to your AutoCAD, and then you can, from your AutoCAD there, you can also take it over from there. But you may want to do your editing directly from here, you can as well achieve that. You can also send your drawing entirely to your AutoCAD and you print. Okay, so if you love what you are seeing, just like this video, give it a thumbs up, subscribe to this channel, it's actually free. Click on the bell icon so as for you to get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Make sure you stay safe, make sure you stay blessed.